Math analysis, this is the no calculator final review. I'm not going to do all the problems on this. I've chosen 6 of them that I thought were a little bit tougher. So this video covers problems 6, 11, 12, 13, 18, and 20 from the no calculator final review. Okay, so number 6, get everything fired up here. Okay, number 6 wants the cosine of x plus 3 pi over 2. Remember, you can't distribute the cosine through or anything like that. This is not a number. It doesn't get distributed. It's an operation. This is the cosine addition identity. So again, if you remember that song, and again, this will be on your final, you'll have this theorem, but it's addition, subtraction, cosine flips the sign, so we know it's going to be negative. Sine is mirrored. It keeps the sign while you double for cosine. So it's going to be cos minus sin. So cos first thing, cos second thing, cosine flips the sign, sin first thing, sin second thing. And again, we don't know anything about x, the angle x, so we can't do anything with that. But 3 pi over 2, we do know about. Again, 3 pi over 2 is 1 over 2. 2 over 2, 3 pi over 2. So it's right down here. The coordinates of that point are 0, negative 1. And remember that these go cos, sine. And so therefore, the cosine of 3 pi over 2 is 0. So this is just 0. So 0 times whatever, doesn't matter, it's gone. The sine of 3 pi over 2 is negative 1, so what you're really just left with is negative sine x times negative 1, which will be positive sine x. And there you go. And again, you will be given the identities, the addition and subtraction identities. Number 11 wants the rectangular coordinates that match these polar coordinates. Remember, this means rotate that many radians, step out from the origin that far. So I'm going to plot where this point is, or approximately where it is. So 5 pi over 6, 1 6, 2 6, 3 6, 4, 5 pi over 6. Build myself a right triangle. 5 pi over 6 means there's only 1/6 left, which means this is a 30-degree reference. Remember, it is out 7. Remember, if I pointed, I faced this way, and I walked out 7 steps. So this is 7. So here is the point, kind of, a little bit. Here's the point, 7 comma 5 pi over 6 in polar coordinates. What it wants is rectangular. Rectangular means left or right movement, in this case, the left movement, followed by the up and down, the typical way you're used to graphing points. Now, without a calculator, you got to be able to do this and remember the special right triangle rule. So 3060, keep it on the down low, use root 3, use 2 times. The short leg is half the hypotenuse. So that's 7, short leg has to be 7 halves. The long leg, actually we'll go another color. The long leg is simply the short leg times root 3. And so now in normal rectangular form, and by that I mean x comma y form, what we're used to, the x movement, you have to be careful here, the x movement was left that far, so that's going to be negative 7 root 3 over 2. The y movement was up 7 halves. So there you go. Again, this means go back and up to get to that dot. This meant rotate, that's 150 degrees, and step out 7. It'll get you to the same dot. So there's your answer, number 11. Number 12 is initially looks kind of weird with that square root of 143, and especially I know that makes you sick to your stomach because it's in the denominator. But this is actually a much faster problem than people have been thinking it is. It says that we want to figure out sine and cosine for the acute angle, theta. Acute angle means less than 90. That just tips us off that we're in the first quadrant. Now, again, if you're given a trig function, it's usually a good idea to make a triangle and figure out what's going on. So this would be my angle theta. I don't know what theta is. I don't really care. But I know the tangent of theta is that over that. Remember, tangent, TOA, tripping on acid part, opposite over adjacent. So the opposite from theta has to be 1. The adjacent has to be a root 143. Now again, no calculator here. But to figure out the hypotenuse, just do Pythag. That squared plus that squared has to equal c squared, so you get 144. Conveniently, 144, so this is 12. Now it just wants the sine and cosine. Well, the sine of of theta. The sine of theta is simply opposite over hypotenuse, 1/12. The cosine is adjacent over hypotenuse, root 143 over 12. And again, since I'm in the first quadrant where all are positive, don't have to worry about negative signs. And there we go. Number 13, this is that inverse trig, which frightened us a little bit. Remember that we want to work this first. This is regular trig. Find the sine of 2 pi over 3. Okay, so I'm just going to, for this part, I'm just going to draw coordinates. 2 pi over 3, that would be 4, 6. So 1, 6, 2, 6, 3, 4 pi over 6. So this will give us a 60 reference. And once the sine is opposite, the opposite of the 60, hopefully we know this by now, is root 3 over 2. And so this is positive root 3 over 2. The reason I know it's positive, all students take calculus. Sine is positive in the second quadrant. That's what I wanted. So now I'm taking that solution to that, but now I'm doing the inverse sine. Now when you do inverse sine, remember that immediately the inverse sine, and we talked about this at length for a while back in February-ish time. Inverse sine, you immediately cross out the left 2. Same thing as for inverse tangent. Inverse cosine, you cross out the bottom 2. Since this is positive number in here, I know I'm in the first quadrant. And again, inverse sine is saying, what's the angle that gives you that for the opposite? Because sine is opposite. 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 Focusing on that. Okay. So, we already know what the angle is that results in an opposite of root 3 over 2. We just did it. 60 degrees. Just we're in a different quadrant now than we started with. So it's 60 degrees, but in the first quadrant. So the question is, what is that in radians? Well, that'd be 1/6, 2/6, which is pi over 3. And there you go. And again, looking at this from the beginning, when we first learned this, I said, hey, be careful. It looks like those should just cancel each other out. Like you should just be able to do that, and you're left with 2 pi over 3. You have the same reference angle of 60 degrees. 60 degrees there, and in the solution it became 60 degrees as well. But we're in a different quadrant. And again, the reasoning is that we have to be between negative pi over 2 and positive pi over 2. This number is not between those. So we had to rework it in the other quadrant. Okay, 2 more here. Number 18. This one takes a little bit more. You will be given this formula. This one requires de Moivre's formula. This we did just about a month ago, or maybe a little over a month ago. Here was de Moivre's formula, and again, you will have this. Any complex number, z raised to a power, here's how you can do it. Take the radius to that power, that's no big deal, and then you multiply the angle times that power. So it's cosine of, I'll say, n times theta plus I sine n times theta. And again, the n is simply whatever the power is. So in this case, the n is 6. Now remember, what we have to do to be able to use this formula, to use de Moivre's, is we have to turn this into a polar form. It has to have that cosine and I sine stuff. So the first step is to get this in polar form. That means I have to plot it. 2 plus 2i, no big deal. 1, 2, 1, 2. Write 2 on the reals, up 2 on the imaginaries. Build myself a triangle. So we got 2 and 2. You could use the 4, 5, 4, 5 to say that this is 2 root 2. Or you can say 2 squared plus 2 squared equals c squared. And then you get root 8. I'm going to call it root 8 just because I know it's going to be easier to deal with the root 8. So there's my radius. And again, right now, all I'm doing is converting this stuff in the parentheses. All I'm doing right now is converting this stuff that's in the parentheses to polar form. That's what all of this work that I'm doing over here is going to be. So I've got the radius. And now I just need the angle. In radians, since I know that's a 4, 5, 4, 5, this is pi over 4. So this number in polar form is root 8 cosine plus I sine. The angle we decided was pi over 4. Okay, so now I have it in polar form. Now what I can do is actually take it to the 6th power. So again, what that means I actually do take root 8 to the 6th power, but then I multiply these angles by 6. The same angle, obviously, by 6. So root 8 to the 6th, let's deal with that. I'll just deal with that over here. So root 8 to the 6th, that means 8 to the 1/2 to the 6th. You can multiply power to a power, so that is 8 to the 3rd. So that would be 8 times 8, 64, and then 64 times 8 as well. So again, no calculator, let's go ahead and actually do it. 32, 48, 49, 50, 51, 512, which, hey, those were in my possibilities for answers, so that at least seems like maybe that's right. So again, root 8 to the 6th, I just found out that that is 512. So 512. And then this is cosine of 6 pi over 4. So I can just write that as 3 pi over 2 reduced. Plus I sine 3 pi over 2. But the 3 pi over 2, I'm going to go ahead and actually figure out what that is, because the answers all are back in rectangular form. This is polar. So the cosine and the sine at 3 pi over 2, well, again, 3 pi over 2, 1 over 2, 2 over 2, 3 pi over 2, which is 0, negative 1. We did this one a little while ago. The cosine is 0, so this is actually the number 0. The sine is negative 1, so the sine is negative 1, so this would actually be negative I. Negative 1 times I. We still have the 512 out in front. There's that part. So 0 is obviously gone. Negative I times 512 is negative 512I, which on your multiple choices, that is nowhere to be found, so that's why the answer is D, none of these. Okay, last one I want to go over is number 20. Another tougher one with the graph. It says we need to find a cosine rule that seems to be identical to this. Okay, so the first thing that will eliminate some of your answers on your multiple choice, the first thing is to note that obviously I moved up, not down. It's slid up. So choice A, here, I'll just do this. And you have this in front of you, hopefully. Choices, let's see, A and D both have -3 at the end. They both have a bunch of stuff, -3. That would mean shifted down 3. It's moved up. So those are gone. So we got to now just at least have a 50-50 shot just knowing that. The other two choices say +3. So 1, 2, 3. So it's saying this is our center line. Ooh, this is going to be a bad line, but we'll see. Get as much as we can in. Oh no, that went left. Oh, perfect. Okay, that's not supposed to look like a sine wave. That's supposed to be a straight line. But, so there's my center line. Both of these choices have a 7 out in front, which means the amp is 7, which makes sense. If I count from here, 1, 2, 3, 4, 5, 6, 7. And if I went down, it's also 7. So that doesn't really help me between the choices B and C. It looks like the big difference is that choice C has 3t minus pi over 6. Choice B has 1/3 t minus pi over 6. Now I'm not going to worry about doing all the factoring. Remember, this is supposed to be factored out. So really that would be factored out. And there'd be a 1/3 and then something, but we're not too worried about that. This would have a 3 factored out, and there'd be other stuff. Now remember what these numbers mean. This is not the period of the function, but what this means is 2 pi divided by 1/3 is the period of this function, which you'd multiply by the reciprocal, flip it, you'd end up with 6 pi. For this other one, for choice C, it's just 2 pi divided by 3. So, period down here. And here's the period for choice B. Now, looking at it, it's pretty obvious which one's going to be correct, but let's just double check. This would be a very small period of the function. It'd be finishing the full cycle, full cosine mean top to top, just 2 pi over 3, which is not happening. If you look on your paper, this peak is about, looks like, -5.5 pi. This peak is at +1/2 pi. How far is it from one peak to the next? Well, how far it is 6 pi. Hey, that makes sense. That's why we know choice B is our answer. So again, just knowing that it was shifted up instead of down, that eliminated 2 answers. And then noting that the 1/3 actually extended the period. The 3 shrunk or compressed the period. This one had to be the correct one. So hopefully this helps with some of those no calculator questions. We'll answer other ones in class.